Welcome back, science students. Today's topic is on acids and bases. Acids and bases are two very important categories of chemicals in the chemistry world. Let's find out what makes an acid an acid and what makes a base a base. Okay, let's take a look at acids first. What is an acid? An acid is any substance that releases hydrogen ions in solution or when mixed with water. Okay? Acids have several key properties that you need to know. Acids are good conductors of electricity. Acids are substances that will turn litmus paper red. Acids taste sour. Acids also have a couple key reactions. Acids will react with active metals to produce hydrogen gas. For example, we take hydrochloric acid, add some magnesium ribbon, and you've done this several times over your chemistry career so far. It will bubble, collect it, and produce hydrogen gas. Acids will also react with carbonates and produce CO2, or carbon dioxide. Those are the properties of acids. Okay, let's take a look at bases now. What makes a base a base? A base is a substance that will release hydroxide ions in solution. So again, when mixed with water. You'll remember from earlier in the unit when we looked at polyatomic ions that hydroxide is one of the polyatomic ions, OH minus 1. Now, bases also have some key properties that you need to remember. Bases conduct electricity, though not as well as acids do. Bases taste bitter. Bases will react with litmus paper and turn litmus paper blue. Bases react with phenolphthalein, an indicator, and we'll learn more about indicators as time goes on, and turn sort of a pinky magenta type color. As well, bases feel slippery to the touch. Okay, so bases feeling slippery. And those are the properties of bases that you need to know. Now, when people think acids or bases, they usually think, really scary, strong acids, burning holes and things, but you eat acids all the time. Citric acid is commonly found in most fruits, and it's something we eat all the time. If you look at the can of Coke and the ingredients, you'll see acids are found in there as well. So acids cannot all be the same strength. Well, how do we measure the strengths of an acid or a base? What we use is the pH scale. The pH scale goes from 0 to 14. Here's an example of the pH scale. And you'll see a number of different common substances found on it. Now, the pH scale is a logarithmic scale, which means that each movement on the pH scale increases the power of the strength of the acid or the base by a factor of 10. In other words, if we have an acid that is pH 1, it is 10 times stronger than a pH of 2. Now, if I was going to compare two other substances, let's say a pH of 4 and a pH of 6, both are acids. We know that the pH 4 is stronger, but how many times stronger? Well, each movement is 10 times stronger. How we do this is a movement from 4 to 5 is 10 times stronger, and then another 10 times stronger, which means it's 100 times stronger, not 20. All right, now we'll notice that the acids are found between 0 and 7. Bases are found anything higher than 7 to 14. So what's right at 7? Well, 7 is neutral. It's not an acid nor a base. 7 is water. So when we're looking at the pH scale, it'll tell us where acids are, where bases are, and can be useful for measuring the strengths of our substances that we're working with. Okay, the next question is, well, what happens when we mix an acid with a base? What happens? We know that acids are lower down on the pH scale, bases are higher up. It would make sense that we move towards the middle when we mix them. Now, when I mix an acid and a base, I don't instantly get a pH of 7. It depends on the quantity and the concentration. But in general, when we mix an acid with a base, we get this common reaction. Acid plus base produces salt and water. If they're present in equal quantities, that's if the acid and the base are present in equal quantities and of equal concentration, then we will get a substance in the end that has a pH of 7, because it'll be water with a salt. And a salt is any ionic compound that we've been looking at so far. Sometimes we think of salt being sodium chloride, but magnesium chloride is also a salt. Okay, mixing an acid with a base is actually a special case of a double displacement reaction. We have two compounds producing two new compounds. And one of those compounds is always water. The other is always a salt. This is what we call a neutralization reaction, because we start with an acid and a base, and they're kind of neutralizing each other, or making it close to or closer to a pH of 7. And again, they'll only produce a pH of 7 if the quantity and the concentrations are equal at the beginning. All right? And that's acids and bases.